All right. Okie dokie. Let us see what we can do today. So where did we leave off? We combined the light into the object. Really? Oh, I guess. Yeah. The one thing is This alone, I can't really control like individual light flickers. But I don't know if I want to do that. But I could just add another float here and be like, this is light flicker. Like light time. Could be light. Flicker size or whatever. Could be a float that just says plus minus range for flickering, but that wouldn't work necessarily. It would need to flicker downwards always. So then here's obj buffer, right? Color is a uint. I actually don't really know how the light color works. I had the light packaged into one int. It's a 32-bit color. Makes sense. How satisfied are you with Visual Studio 2022? I mean, it's fine. It's just like every single thing that they try to like add or change is ass every time. Hold on. What is this? This is such a stupid question. What best describes your familiarity and usage of Copilot in Visual Studio? Used Copilot in VS within the last month. Used Copilot in VS before, but not currently. Aware of Copilot in VS, but never used it. Was not aware Copilot was available in VS. Like, what are you gleaning from this information? Except, like, that somebody might not know that it exists. This has nothing to do with it if it's, like, useful or anything. This is just, like, I mean, I guess. Mm-hmm. Okay. So I'm just thinking, because the light data is being set up here separately now, but the light data actually needs to be set up in a way where it's like available from the object. Right, so light source list, right? I think that can still kind of work. But it should be a... How does a hash set work exactly? Oh my god, oh, the documentation is so bad, bro. Like, this is a hash set. Okay, what is it? Like, why isn't there a little description? Represents a set of values. Fuck off, man. Like, oh my god. This example demonstrates how to merge two sets. What? Why don't you demonstrate what a fucking hash set is in the first place? Oh my god. But how am I supposed to take something out? I mean, it needs to... Okay. Oh, yeah, I do have IDs. Well, no. No. No, we want a dictionary, not a hash set. Yeah, we want a dictionary. Man, what is it I need to do here? I'm so not in the right headspace today. Like... Instead of the light sources being in a list, they should be in a dictionary. That way, what we can do... Well, I don't know. If the light size... It doesn't need to be written. It only needs to be written anytime that the object updates. Like... Hmm... Yeah. So really, any time that the object updates... which is going to be all the time. I mean, technically, it doesn't matter. But technically, I don't need to... Like, I don't actually need to rewrite any light data just for updating positions. I just realized, like, because if you put an object into, like, here's our buffer. Our buffer B. And then you have an object. And the object consists of 3 parts position, 1 part light size, 1 part light color. Then the way this is going to work is that we put this in there into the buffer, and then it repeats this in this manner, right? So what you could just do is you could just say, you could just make a kernel in the buffer or in the shader that says right position to object list. And then all you need to do is just take a vector 3 and then just write it in here at 0, the first 3 at 0, and then the next one is at 5. So you can just overwrite individual data like that. Oh, that's interesting, actually. It's actually very interesting. I don't know if it really makes a difference right now. Static grid matrix buffer needs to be baked into tiles. No. I mean, it could be actually. Right? I don't think it should be. So the question is, where exactly do we write all of the object data and when? Because here we have compute object data, but it's not being written in the object at all. So we have the pre-render step. Here we dispatch and set the current sprite, or we do the current sprite stuff here. Opacity. So I'm thinking, where am I calling to do stuff? I'm not really. But I feel like it should be... we handle it at the beginning of late update, maybe? Because here we have world container late update. Update world index buffer. Write to tile data buffer. Update C shader buffers, right? So it should be somewhere before this, but I mean, I don't know really. Maybe I just do it in here. Like maybe the object is just different. And the object buffer, I think, should always run. It should always run. Object data is written every update. Now, I think that's not actually true. Should be written every draw frame. I guess. But let's not worry about that for now, because it's one of those things where... like, how do we handle frame rate limiting? For example, all of the sprites animate at the same speed. But then the question is, should they be able to animate at a faster speed? I mean, probably, yeah. Because otherwise, I could just set a timer that just updates sprites at a certain interval. But I think, again, I'm just worrying about unnecessary things. Hello, Ho Ho. It's going slow. It's been a slow week for me. But we are making progress. I'm just trying to decide where I should be doing things here. Basically, I'm moving writing light size and stuff into the object here. And now we're gonna do that every frame. This, let's see. It takes light size and, oh yeah, it needs to bake the light color into an integer. Should I actually bother doing that? Because that's me trying to save bandwidth. But like, who cares? Object data. Let's see. Light mask. Light color. Yeah, the light color is a color. I think I would rather... So I have a few options here. I could just write the color as a float 4 on every object. But that means that every single object is now 32 bytes or 32 bits heavier. But it doesn't matter because it's like 100, 200 objects max. 200 times 32 bits, who cares? Literally has no bearing on anything at all, right? So I could just set it so that every object has a light color, always, even though it is not a light source. But that means that every object needs to have just garbage data written to it, basically. But that's not true either. Because we can just update the position. Without writing extra false data. Like I said, with this. That way we can keep light data inside of the object buffer, but we can still update the position without writing light data by just writing raw data into these positions. So yeah, there's no problem. We can do this. It does make it complicated, though. I think I'm just gonna not make it complicated for now. And then we just say that color is a color. Wait, can it take a color? No. How do I... Well, yeah, a color will be Hold on. It can just be a color. Okay. Three, 4. This is now 8 in size. And then we just write the color, dude. And that's it. And then in the kernel, we then have a byte offset here that's no longer 12. It's because a byte 4 times 8 is 32, right? Yeah, so it's 32 times 8 divided by 8. Yeah, so this is now 32. But this is no longer just load 3. Okay. Okay, so we then need to specify what everything is. So this is not raw, this is raw, this is position. And then we have a a float. No, it's a uint light size. So staging buffer dot load byte offset plus 12. Because that's then where we start and then we offset it by another 12, which is the position data. And then we need a uint4 light color, which equals staging stay dot load 4 light offset plus 16. And then data dot, are you fucking kidding me? Light size equals as float light size, and data dot, holy shit, data dot color dot r equals as float light color dot r. That. So then here we're loading in the object data. I'll be right back. I need to blast some music. There we go. Maybe. Oh. Okay, color is a uint here. Let's set it to a float 4. But yeah, so basically, this is how you upload a data object, but what I could do is I could write update object position, and then it only has a buffer that contains positions, and then it just writes it to the correct data positions inside of the object and just overwrites like that data segment. But it doesn't matter. It just doesn't matter. If it was for tiles, it would matter, because the tiles are, there's so many tiles, but there are not that many objects. Let's split this out. This is wrong. And this one, update dynamic shadows. This doesn't exist. This doesn't exist. This doesn't exist. This doesn't exist. Update static light buffer, dynamic light buffer, static shadow buffer, dynamic shadow buffer. These things don't exist. Here. Compute static light source buffer, compute dynamic light source buffer, compute static shadow source buffer, compute dynamic shadow source buffer, compute... Yeah. Those go away. This should not be like that. See, static light data. Dynamic light data, shadow data. Oh. Okay. Object master list, sorted list. This should be a dictionary. I'm just thinking. So the way it works now is that we draw the object to a texture, a 3D texture, and then when we to render it, we access it through there. I think the texture should be like a pre-allocated size. I wonder what's the largest. How big should it be? It's like, what would the largest size of an object be that I would have? It's a tricky question because I could need to have like a big tree or something. Be something. Like this is 320. And the tree is like this big. I'm just thinking what would be practical. Because let's say it's 32 bits, right? So 32 times 512 times 512 times, let's say 200. That's 209 megabytes. If we make it 1,000, but that's, I just don't think 1,000 is reasonable, because that's bigger than the screen. Do I ever actually need an object that's bigger than the screen? That wouldn't be better served as a tile solution? I don't think so. And on top of that, you could just use like 4 segments. Like if it needs to be this big, you could make it be 4 pieces too. It's 500. I think that's more reasonable. Because what we're gonna do then is we're just going to give the texture... I actually don't know what it's called or where it is. Pre-render. We have a read-write texture here called result. Which is output text. And output text is currently set to base resolution. No. What? No, this is a different... This is C shader. Here. Obj collection text. And here it's being set to have 0 depth. How does this work? Oh, here. Yeah, okay. You set it to volume depth here. So currently it's set to 512, 512, and then it has a volume depth of 255. All right. Well, that's okay then. Because what that means is that it has a fixed size. So that means that we can just access it, right? Like, all we need now is a render order, and that's it. So the render order list will contain the index, and that index will then point towards the object. It will point towards the light. Technically, it will point towards its texture in this texture. It should handle everything. This index should be obj index. No, it's called ID. That's what that should take. It should not take an index. Yes, that makes sense. Update static light area buffer. That does that. And then that sets this. So here. Static light source matrix. That's a list. That should contain... This should be... sorted list. I think. I mean, it doesn't matter, does it? But... Or should it be dictionaries? I don't know. They just need to be hash sets. This is an actual case for hash sets. right? So hash set, and then we just make it be an int. Yeah. All right. It's because they're arrays. Because all they need to contain is the ID, right? Like, the hash set only needs to contain the object ID, and that's it. And then we can just write all of the every object that's contained, or every ID that's contained in the hash set can just be written in random order. So we can just do like for each and then write them out. And that's it. Because it doesn't matter which order the light sources come in. When we are checking against them in rendering. Light order shouldn't matter. Actually, is it a uint? No, it's just an ID. It's an int. The hash set has a count. Hold on. This is just half of it. I didn't finish this. So this is the light area. This is the area buffer. All we're doing here is we're setting static light source matrix. This is the light area count. This is different. Okay, so this needs another loop. I'll be right back. Completely forgot what I was even saying or doing. I got caught up in thinking about steaks being better when they're well done. Sick of front-end Python? Yeah. Honestly, coding in anything that isn't a C language makes me very sad. But honestly, I only like C#. C++ is stupid. I'll be honest. C# is, in my opinion, the language that makes the most sense out of any programming language. I actually haven't really seen that much C, but I assume it's kind of dumb, just like C++. But it's like, I just think C++ isn't human. Like, I feel like it's too ancient. And that's what the entire point of C# was, making it, like, more human. So to me, it just makes more sense. So, like, I've looked into learning C++ sometimes, because I've been... I want to write, like, procedural generation and world generation and stuff like that, and when you're doing those kind of, like, 3D voxel type games, it does matter whether you're using C# or C++ to some degree, right? It's, you need to be able to manage memory in a better way. But I don't want to do it. I don't want to. Alright, let's see. Where was I? Static light source matrix. So here we're setting the count and the stride. So then we need to create we just need to write the object IDs. So it's just gonna be like this. List int light object IDs list equals new list. Then it should just be done in here, right? Because here we are iterating through the static light source matrix, which is a jagged array of hash sets. So as we're iterating through this, we just do... Actually, I don't know. I've never used a hash set before. That's why I'm a little like... How do you actually access it? I think we have to... We have to do a for each in here. And then we say... For each item in the hash set, we're gonna say... light object ID list dot add item. And that should be it. So then we transfer all of the hash set entries into this ID list. Then we write the count of the hash set into the stride. Then we bake the stride into the baked int, and then we have a start index, which starts at 0 and then gets the stride added to it. That way, we have one buffer that contains the IDs of the light sources in the area, and we have another buffer that contains the start index and the count of light sources in that area. Then this here, static light area buffer manager, this needs to be set to light object IDs. This is the compute static area. Compute static light area buffer manager. So we need another one that's called compute static light area. What do we call it? Ride buffer manager. Right? Stride area buffer manager. This could all be in one buffer, but fuck it, whatever. Static shadow area. Stride buffer manager. Dynamic shadow area. Stride buffer manager. There. Then we also need to create these fuckers. Static light area. Stride buffer manager. Dynamic light area. Stride buffer manager. Shadow area. Stride buffer manager. Shadow area. Stride buffer manager. Light area map size. Now the area, light area, this isn't correct. Light area map size. How big should it be? I'm just gonna make them like 1,000. Stride. So the light area buffer manager, they need to be 1,000. We're just using magic numbers right now, because why not? So basically what I'm doing right now is I am creating an area system for rendering lights so that we can have, I don't know what the correct term for this is, but basically so we can say that, yeah, light 1, 3, 5 are here. Here we have light 7, 8, Oh, and also light 1 also overlaps there, so there's 5. And that way, whenever we're rendering a pixel within this zone, we only need to check these lights, right? That's what I'm doing. What do I need to do now? We were working on static light area buffer, I think. Here, yes. So this is the static light area buffer gets set to light object ID. But this is also incorrect. Because this shouldn't be set data anything here. Because it's an immutable buffer. So what should happen here is that the compute misc staging buffer should have set data light object ID list. And then we should say is it just called staging buffer? Yeah, right now it's just called staging buffer. That should be set to that. And then we need another kernel here called upload static light data. But this one is not right. This doesn't exist anymore. So this is now upload static light area data. And then we need another one called upload static light area ride data. And so the area data is... it's got a byte offset of 4 because it's an integer. Wait, hold on. The byte offset needs to be x times 4. Yeah. This actually doesn't do anything, now that I look at it. No, here it is. No, there it does. It does write to the compute object data buffer there. And here we are static light area data. So this is gonna be compute. Static light sources. Compute static light areas. This is now a read-write structured buffer, which takes uints. So this should be shit. This is confusing things. There's actually no real reason for it to be a uint versus an int. It doesn't matter, because we're not gonna have 2 million objects. So here we have a compute light data, static light sources. This one doesn't exist anymore. So we have the compute static light areas. But this should now have a light areas stride. I genuinely don't know why I'm doing uints everywhere in the shader. That just kind of started happening for some reason. Oh! Static light area data. So here then we have that, and this should actually have a struct, I think. Or, let's see. We can just make it a uint 2. Compute light area stride is a uint 2. And this one is a uint 2. And the shadow also needs to be the same way. And this also needs to be static and dynamic. Dynamic light source count. Dynamic static light source count. This doesn't matter anymore, but we could write a total for the stride. I don't think that's actually necessary, but it's not necessary, so let's not do it. Because the stride will always have a stride entry for every area. So it would have to be like trying to render outside of the world or something, where it shouldn't be doing anything anyway. And we're not using light sources in that sense anymore, so all of these can be deleted. So then we go back down here again. And here we're loading a raw integer from the light area data. And that's just compute compute static light areas. X equals as uint raw. Yeah. And then upload static light area stride data. This is then a little different. This is gonna fetch this as a uint raw. And then we need to say uint unpacked equals as uint raw. And then, well, let's say packed. And then we have to say uint count equals packed and man, it's been a while since I did this. Let's see, programmer bitwise. So we have half an integer assigned to this, so it's gonna be equals packed and 65535. However, this doesn't work. You have to do this and then convert it to a uint, otherwise you get an int and then it becomes weird and shitty. In HLSL, you actually have to, I think you have to wrap it in a parentheses or something like that. I remember doing bitwise stuff in HLSL. It's a little finicky. You have to do like certain things, otherwise it just doesn't work. But either way, that's the count, and this is the stride, and that's gonna be packed shifted by 16. And then we fetch the first 16. And then that should be stride. And then we're gonna say compute static light area stride x equals uint2 count stride. Let me remove this. Oh, it's not count, it's kind of the other way around. It's start index, and the stride is actually count. Like that. I don't know if stride is the correct phrase or terminology to use here, but for whatever. Right, and I think that should work. So now, unfortunately, we just need this same thing for all of these. Dynamic, Dynamic. Dynamic. And then this is static shadow. 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 Dynamic shadow. Then we go up. Upload static light area data. Static light area stride data. Dynamic light area data. Dynamic light area stride data. The static shadow area data. Static shadow area stride data. Dynamic shadow area data. Dynamic shadow area stride data. I think that should be right. Whew. And then what else are we missing here? We need to set a few more things here. Staging count. This is static light area. Let's see. Shader dot dispatch kernel upload static light area data. Can you create a local scope by just writing brackets? Like this? Mm, yeah. A block statement. Okay. Fair enough. Yeah. I like that. My brain's cooked. My brain's cooked. Holy shit. I've been so tired this week. It's been really bad. And this is very, very mind bending right now. It's fairly easy, to be honest. It's just connecting the pieces together correctly is a little bit overwhelming because there's so much stuff going on here right now. But basically all we need to do right now is finish writing this, and then we just copy the solution over to the shadow, to the dynamic and the static versions, and to the shadow segment as well. That way we'll be writing area data that is just index pointers towards objects in the object list. And so every object carries light data, whether they have light data or not. So it's just going to be like the zeros or actual light data. And an object will be counted as a light source if it exists in one of the light area buffers. And then it will try to read the light value, whether that's 0 or an actual value, right? And if it's 0, then it just won't really try to ray trace towards it because it's going to be too far. Like, It's not going to be within... Oh, actually, maybe it doesn't really matter that much then. We'll see. But yeah, that's basically it. I don't know if I actually finished the description there, but... There's just like one optimization that I've been kind of worried about a bit. And it's like, do I actually take the time to add and remove corner areas that don't fall within the circular light, or do I just keep them in there? Because if the light falls within an area, but it's not like actually there because it's not within the distance of that area, because it's circular, then that means that every pixel that renders in that area will still have to check itself against that light. But I don't think it matters now that we have the lights in an immutable buffer. I don't think it matters, so I think I'm just gonna make it easy and then not bother. Because it ran fine before when it was in a sub-update buffer, which is like 10 times slower. And we're also going to be able to fix a lot of the register issues in the shader once this is done, because I'm just doing things differently. It'll be a lot easier to just load and read data. But we should figure out how this should look here. So the staging count for this is if we just do the light object list first, then that's going to be like that. And then we have to set which kernel, and it's going to be kernel upload static light area data. We have to fix the kernels, because this is now static light area stride. Dynamic light area stride. Static shadow. Area stride. Dynamic shadow area stride. Static light area stride. Dynamic light area data stride data. Dynamic light area data. Static shadow area data. Ride. Okay. Upload static light area data, upload static light area stride data, upload dynamic light area data, dynamic light area stride, dynamic shadow area stride. Okay. There, we dispatch that, and then we're gonna say and then we need to do this. This is now light area data array. Staging count. The buffer, the C shader buffer needs to be set here. This is compute static light area buffer manager. And here it's compute static light area stride buffer manager. And then as such. And then this is not. Let's hold on. This is compute. Right, the compute MISC staging buffer needs to have set data, compute static light area stride buffer manager dot buffer. No, it's set to light area data array. That's what it's set to. And then this is set to this. And then it's dispatched. And here we need to do the same thing here, but this time it's that. And this is set to this. So then here we upload the static light area data, and here the static light area stride data. Okay, so apparently you don't need to do set buffer. That's just like a binder. So you only need to do set data. And then... So this, the staging buffer call, this only needs to be set on buffer creation. So here we say something like compute C shader dot set buffer. Hello, ha ha ha, 1, 2, 3, ho ho. Let's go. How long have I been programming? On and off for like 12 years. So we need to do this. Staging buffer. What would you say is your favorite programming language in general? Easily C#. I think C# is the best language to work in on a professional level, and I think it's the best starting language for anyone. I think it's the best language. There are other languages are better in terms of like raw performance in certain cases, but overall I think C# is by far the best programming language. For like 99% of everyday use. What do I need to enter here? There. Why isn't C++ better? Because C++ is fucking retarded, that's why. Like, you don't understand anything in C++ without having studied C++. In C# you can just start and you can start programming. Like, almost immediately without understanding anything. You just need to watch, like, a tutorial how to get started and how to, like, get your foot in the door. And then you can just figure everything out almost logically. Like, you need very, very, very basic rudimentary info to work in C#, or in C#. In C++, you can't do that. Not even a little bit. So how many do I need here? 1, 2, 3, 4, 5, 6, 7, 8... 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11... 10 maybe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then this should be CS, kernel CS main. And then everything except for tile data. Kernel. What about Python? I hate Python, but it has its use. But working in it is a nightmare. I don't think there's anywhere you can go from C# that is an improvement, because the only reason that I would ever say to move away from C# is if you have a reason to. Like, programming in C++ or in C is a complete meaningless waste of time unless you need it for a specific reason. Like, you need it for performance reasons. And you know why you need it for those performance reasons. In almost every single use case, C# is going to be good enough, because it's not slow at all. And if you're gonna go to like Python, again, the only reason to use Python is if you have a specific reason to use it. Like if you're writing something for like an OBS plugin that uses Python, then yeah, you might want to use Python. But Python doesn't have any real advantages otherwise, other than like you can easily write a Python script in just like a text file and just be like a quick thing that you can just put together. But otherwise Python is just ass, because it's a higher level language, so you need to like... The thing about high level languages, if you don't know what that means, it's like another layer of abstraction between machine code and like human-like code. So it does things for you. But the more it does things for you, the more you have to know how it does things for you, and you have to like know everything and how it works, and on top of that, it's just a chore to work with, to be honest. Like, honestly. I don't think it makes as much sense as C# does, but I also have more experience in C#. The only real use case for it is that it can be quicker to just write something, because you can just do that in a text file and it just works. But holy shit. It feels a little bit like being a web developer when you're working in Python. And being a web developer is horrible. Working in like Node.js or something, you have to know how everything works, and you have to know exactly like what they want you to do things in certain ways. And like Python isn't like, it's not that bad, but it is in that direction. I don't like working in it at all. C# is at a stage where it makes enough sense that you can just, with just basic if statements, you can figure out everything and like get everything to do what you want it to, more or less, and just go from there. You learn if statements, for loops, what a list is. You're good to go to program most things. Do you think learning straight raw machine code is a good idea? No, I don't think so. Why would you do that? The thing about programming is it's generally about what you need it to do. If you need to learn assembly, then you'll do it for a reason. Otherwise, it's meaningless. Same thing with working with programming languages. Just like making a game in JavaScript is stupid, in my opinion. Because it's not easier, like, oh, I know JavaScript, okay, but picking up C# takes literally like 4 hours. So it's like, I don't know what you're doing, really. So, yeah. I think C# is absolutely... If you want to know programming at all, you should learn C#. It's one of the best staging grounds for learning any other programming language anyway. You learn how to program, and then you can learn languages after that. Because learning languages isn't that hard. Well, unless it's like C# or C++ or C. Something like that. Because working with C or C++ without knowing how it works is like every single inch of programming is a landmine. And you have to figure out like how everything works. Because everything works in a specific way and you have to know how that works. If you just want to look cool, then I don't care. Do whatever you want. So, and then here... Oh, I need to change this name immediately. Staging buffer. This should be named... MISC staging buffer. Fuck! It was set to current project. Current document, please. There. Am I using libraries? Do you even know what a library is? So all of these are now called... Well, let's do a... There, and then we should change this to MISC staging buffer. With those. And this is kernel upload tile data. So here, these should be called staging buffer. And here we have a tile staging buffer. This is a tile staging buffer. And then it should be this. Like that. And yes, I'm working with Unity, so Unity comes with a bunch of libraries. I think you should ask, like, ChatGPT these things. It'll probably give you better answers. Um... Now we have staging buffers set there. We need to continue with the update CS. So now we need to copy and write this for the others. This is static light area buffer. Dynamic light area buffer. We only need to copy after where the start index is, I think. Let's just overwrite the whole thing. And then we change to dynamic. Upload dynamic. Dynamic. Static shadow area buffer. Damn it. Kernel upload. Static shadow area data. Shadow area ride data. Rename these to shadow area just so it makes sense. Holy shit, what just happened? What? Huh? Why does it do stuff like that? Okay, light area data. Rename it to shadow area data. Shadow object ID. Dynamic. Dynamic shadow area derived data. So that should be it. These shouldn't even exist. Starting index. Yeah, no. I'll be right back. Three hours. You just need. Oh wait, what does that mean? Yeah. Okay. The buffers make a whole lot more sense now. So now... I think we're actually almost past the worst. The worst is the right to tile data buffer here. Which I'm not sure if it's finished. It might be. It's not, this is not finished. Because here I need to write... We need to write this using the, this new one, using the staging buffer. So this does need some work. Holy shit, do I have it in me to fix this right now? This doesn't make sense. No, okay, no it does. The tile data to the right is a strip of tiles. I'm just thinking. Because what I could do with the tile data is that I could add an integer to it. And then the integer just contains an x, y, and a z. Let's look at the bits. Right, so we clear this. We would need maybe what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's actually quite a lot. If we make it 12 bits. I mean, what am I doing? I'm doing this shit again. I can just have an X, Y, and a Z. So what I'm thinking is that let's see. Yeah, so I don't think that the tiles should be dispatched. As little individual things. It should be like... There's no necessity for any real kind of data structure when you're writing raw data. So what I could do is, in the same fashion as we're writing stuff here, we could flip this around and say that the pink is tile data. And so what I could do is we could write some data here in the buffer that says this is X, Y, and Z. And this is count. It says like 10. And then we just write 10 tiles into the buffer. Just like that. And then over here at the end of those 10 tiles, we then have this again. And it just contains an XYZ and how many it should write. That way, we can pack the tile buffer full every dispatch. So that way, we don't have to dispatch it like 40 times just to draw a line of tiles vertically. And this will just be one dispatch. I think that's the play. That way I don't have to have a... Because the way I have been doing it is that I have an integer here on the side that says like it starts at 0 and then it's got a count like packed into it that then says whatever. That way we can bake that into the raw data. In theory, but how do we do that on the C# side? How do we create that raw data? Because right now the data is a list. Maybe I can't do that. Hacking the data manually. You need to use memory stream binary writer. Oh. Fuck is Little Endian? Little Endian. Byte ordering method. Where the least significant byte is stored at the lowest memory address. What kind of computer system doesn't do that nowadays? Yeah. Power PC used in Xbox 360 and PS3, both big endian. Jesus Christ. Why would they do that? ARM. Nintendo Switch uses ARM in Little Endian mode, so even that's fine, but older Nintendo hardware... Wii U, GameCube was Power PC Big Endian. Oh, yeah, whatever. Doesn't matter. Memory stream. Using system.io. Var ms equals new memory stream. Total byte size. Do I know what the fuck the total byte size is? This is a little complicated, but I think it's entirely doable. Basically, we'll have to create 3 lists. I think, or maybe not lists. So we get the temp tile data here, right? Okay, so we use a byte list. Bit converter. Okay. So, tile data to write contains the XYZ and the tiles. And tiles are just one integer. Is that true? No, this is the amount of tiles to write. And then we need to create new compute tile data into this list. And once we have done that, then we can say raw data dot add range bit converter get bytes start index and then no, it's not gonna be start. I mean, yeah, why not? And then we want int count equals 0. This is then gonna be temp tile data list dot count. Count equals and then we add the count. And then we write the compute tile data in order. 1, 2, 3, 4. But in a for loop. Right? And then we're gonna say temp tile data list dot I dot it's tile data, building ID, room ID, roof ID. And then we create this here. This is raw data. And then we just spam that in here. Here we have to check if tile data to write q dot peak dot tiles to right dot count is greater than +2. We basically have to make a check here. Int bytes written. Bytes written plus equals 8. And then here it's gonna be bytes written plus equals 16. Or should we say int written? That way we can just say, to have it make a little bit more sense here, for, because everything is an int here. So if the tiles to right times 4 plus 2 is greater than maximum length, else then here we're gonna say int written equals 0, count equals 0, start index equals 0. But that's only after we execute the thing. Because then here we need to say compute staging file staging buffer dot set data raw data. And then we just say cshader dot dispatch kernel index is kernel upload tile data, and this is then raw data dot count divided by 64 mathf ceil to int. Holy moly. Ooh. Yeah, what happened to bytes written? Oh, it's int written. There. I think that should work. We don't need a buffer set there. I think that should be it. Unless I'm forgetting something more here. But basically... Oh. What we're doing then is we create a list of bytes called raw data. And then while tile data to write queue contains more than one entry, meaning there's tile data tile data to write. We then dequeue the tile data. Oh, there's actually one more thing. We dequeue the tile data. Then we clear the temp tile data list because it's being set here. So we're just, this is just so that it works for the remaining iterations. Then we loop through the tile data to write, which is a struct that contains a list of tiles to write to a certain XYZ position, and how many tiles to the right of it in X that it needs to write, because it can only write in strips like that. Kind of. And so we then create the compute tile data, which is everything in the tile that we need to... Basically, it... Yeah. It contains the baked tile data in here. And then it contains the starting position in X, or in X, Y, and Z. So we access the tile matrix there, and we then write the tiles to right count to the right as the for loop iterates, and we write the building ID, the room numbers, the roof, and then we create this temp tile data list that contains all of the tile data. Then we grab the current count. We create raw data here that's kind of like a header that contains a start index, which in this case is 0, because this is the first one. And it contains a count, which is basically like the stride. And then we write how many ints we have written so far. And then we write all of this tile data in sequence after this. And then we add how many tiles we've written in ints. So now we have raw tile data, building data, room ID, roof ID. And then we just go back up here again to the while loop. If the count is greater than 0, then we just continue here. And if we have written so many tiles that we have exceeded the maximum size of the tile buffer, then we go in here, we set all of the raw data that we have written so far, and we just dispatch it to the kernel upload tile data, which then is supposed to handle moving the data out of the buffer and into the tile buffer. And then we reset all of the int written, count, start index. And then we continue the while loop, which then continues here, right? But what it needs to do here now is it needs to say if tile data to right q dot count equals 0, then it needs to do the same thing there, here. Because then we're done. And then it's done. And then, in the shader, this needs to be handled, which will be a little bit more annoying, I think. Let's take this one. Call this upload tile data. We should set this. Staging count. No, that's not accurate. staging count is just raw data.count. Means we don't really need that int there. Okay, so we have basically this is a little complicated here now. But it's gonna be like so the byte offset is gonna have to be something like x times... I think it needs to be a for loop, actually. But it's gonna be like tile staging buffer dot load int location 0 as int Does it need to be a while loop? So basically, we need to say current start index that's how it should be. And then we're gonna say current start index equals as int file staging buffer dot load current start index plus current count. And then current count equals as int file staging buffer dot load current start index plus now these are byte offsets. So this needs to be times 4. And then this is current start index plus 1 times 4. think that makes sense. And then here we need to say current index equals x minus current start index. And so we can say that uint4 equals tile data raw tile data equals tile staging buffer load current index times 4 but it should be load 4. And then we say tile data compute tile data dot tile data equals raw tile data dot x as uint and then building IDs, room IDs, roof IDs. This is then X, Y, Z, W. Something's missing. We don't have the XYZ here. Why no Z? Oh no, there's a Z there. We made it. But yeah, it needs an XYZ as well, which is going to complicate this a bit. Raw data dot add range bit converter dot get bytes tile data to write dot start position dot x. And so this is 5. But this is not, it's wrong. It's a little bit wrong here, because we're not including the... Because the start index... The start index is actually never updated here. So that does need to be updated here. And then temp tile data list dot count. Start index plus equals 4 plus temp tile data list dot count times 4. Let's see if let's count and see if this will be correct. So at 0 we have start index, 1 is count, and then let's say we have one entry. This will then be X, Y, Z, and this is tile data. This is BID, 7 is room ID, and 8 is roof ID. That means the next start index should be at 9. So if we have a start index of 0, and then we increment start index by 4, then that's 4, and then we add one segment of this, that's another 4, so that means it starts at 8. So that's incorrect, because it needs to include itself in the count. So it needs to be 5. But this is also kind of wrong. We actually need another variable here called int total tile data. And this is what we should actually be doing. Like, we shouldn't be doing the raw data dot count. We should be doing total or tile data divided by 64. Same thing here. And the reason for that is because the dispatch is kind of like a for loop in a way, where every instance in the dispatch is like x equals 0 or x equals 1, etc. And what we're doing here is we are baking in raw data that is pointing us to the data. So all of this x, all of these x indices that we are using to write data, they can't correspond to this. They can only correspond to these 4, which means that if I use the amount of data written and send dispatches based on that, it'll be too many dispatches. So it should be based on the total tile data, these 4, and these just help us find them. And so total tile data plus equals 4. No, it's gonna be 1. Because we fetch all 4 of these for each. Yeah. Right? And then the current start index. See, it's got a current count. So it needs to be like tile segment times 5. No, tile segment times 5 times 4 plus current start index plus current count times 4 because that represents the start index, count, and positions in the data. So we need to do that there. And once we get the current start index, then we need to add 5 to that. What do we need to add? Let's say we're at 0 and we want it to start at tile data. Yeah, we need to add 5. And this doesn't work either. Fuck. Oh, this is so complicated. I don't know if I can make it through this today. I'm gonna try, but holy shit, this is... So int should be total non-data offset. Non-tile offset equals 0. Actually, it starts at 2. So total non-tile offset equals 2 5 plus tile segment times 5. Times 4. And then here we say tile segment plus equals 1. And then here this is total non-tile offset plus current start index. No, this is incorrect. Current start index No. We just need a total... We just need a current count. while current count is less than x. So current count plus equals as int current start index plus 1 I know a way to do this easier. We go back here, and here we write count, right? And that's just temp tile data list dot count. What if count instead is everything together? So the count is like entries. So we have a start index of 0. And let's say we have 1 entry. Then we want the count to say and it's wrong in the first place. Yeah, let's say that the count is data entry. And then we do math backwards from there instead. So start index is 0. Then the count is count times 4 plus 5. 5 plus count times 4. Because then that's the count always contains the start index, the count, file data to write.
That way, what we can do here is we can simply say, while current count minus x, or is less than x, then we say current, let's call this current tile count, because that's what matters there, right? So current tile count equals 0. Then we'll say current tile segment equals 0. So total non-tile offset, 5 plus tile segment times 5. Current start index, let's start there. Current start index equals current start index plus current count so that loads current start index here, which is 0. And then this says current start index plus 1 as int. That's the current count. And then current tile count equals current count minus 5. I don't think we need the tile segment anymore. Because that way, we're now getting this correctly. We're jumping to the next tile segment by saying current count, which includes everything. And then while current tile count is less than x, we then continue. No, this needs to be plus equals. And then this is divided by 4. Because the tiles, this is the count, current data entry count. Let's call it that. And then we subtract the 5 data entries, which is the XYZ, the count, and the starting position. And then the tile consists of 4 data entries each. So we then divide that by 4 to make it be 1 tile. We don't need the non-tile offset. That's for sure. And then once we get down here, what we're gonna say is int3 xyz equals well, let's say no, you can just do this. Int3 as int. I don't know, whatever. Let's just do this. Tile staging buffer dot load 3 current start index plus 2 times 4 int3 xyz equals int3 as int xyz raw dot x doesn't actually need to be an XYZ. Which would save space. It just needs to be a value. It needs to be a 1D index. Because we have to convert it to a 1D index now. And then we just say plus x. No. Plus x minus current start index. No, that one's not right either. And it's too much. I don't know if I can finish this. My brain is completely sauced. I know what I need to do, but I just can't think of it. All I need to do is we need to convert the index to a flattened coordinate. Then we need to take the current tile count It needs to be current index equals x minus current tile count minus 4. Or... No, that's not... No. I'm getting all mixed up because each tile is 4 byte segments and we are actually using tile segments as the count, so it's not it's not tiles. So but the tile count is, we've divided it down from tile segments, so it should be minus current tile count minus 4. No, minus... No. Current total tile count. But we also want int current tile count. Which is current data entry count. Why is this a plus equals? Yeah. So here, when we find this, we'll say current tile count equals this. And no. Oh, we don't need that. We need... No, we do need that. We need current tile count. The current coordinate is the XYZ plus X minus current total tile count minus current tile count and then fetching the raw tile data is going to be current start index plus 5 plus X times 4 right? So this is 0 plus 5. Then we go 1, 2, 3, 4, 5. That's where tile data starts. And then compute object data. This is then the flattened chord equals compute tile data. Oh! I think. Oh my fucking god. It wasn't a no, it was some... I think I finished it. But I was so cooked in the brain, I'm sure it's wrong. Holy shit. Oh my god. Game time? I hope so. I'm gonna make some entrecote first, which sounds very fancy, but I actually don't really like it that much. I like just ground beef better. But I'm gonna make it well done this time. I like it better well done. I've been getting memed into not making it well done, but honestly, it's better well done. That's just how it is. Is it a steak of some kind? I don't know what it's called in English. Isn't just an entrecote? Entrecote is French for ribeye steak or rib steak in English. Okay. Yes. It was short date, so I'm trying to finish it off. But yeah, it's got all kinds of cartilage in it, and it's super annoying. And honestly, I just don't like it when it's not well done, so I'm just gonna well done it. People say that it's like eating a shoe when you make it well done, but I feel like when you don't make it well done, it feels like you're eating rubber. Like it's... You can't chew it, it just kind of moves around in your mouth, it's terrible. And honestly, I think it's like, people say that it's harder to chew, but I think it's easier to chew it when it's well done. I don't get it. I genuinely don't understand what people are on about. But yeah. We are writing raw data to the tile buffer. And hopefully that makes sense. But I can't test it right now, so. Cut mine into thin strips. Yeah, I don't cut them that thick either. But yeah. We'll definitely play some video games. We're not doing any coding today. My brain does not have that in it. I do want to do that tomorrow though. Assuming nothing happens, but yeah. I'll be back as soon as I've eaten, unless somebody contacts me about something, and then I'll be on later. So, until next time, thanks for hanging. Have a good day. Bye-bye.